Welcome back to week 3 of CSE 240. In this lecture, we're going to start to talk about arrays. Overall, in this series, we'll talk about one-dimensional arrays, C-strings, and then multi-dimensional arrays. This first video will focus mainly on one-dimensional arrays and C-strings. So a data type, again, is called simple if variables of that type can store only one value at a time. A structured data type is one in which each data item is a collection of other data items. So an array is one such data structure. So an array is a collection of a fixed number of components where all the components have to be the same data type. In a one-dimensional array, all of these components are arranged in a list form. And this is the syntax for declaring a one-dimensional array. So I have the data type, which can be an int, double, string, object, whatever, the array name, and an integer size. Integer size has to be positive. So here's one example where we declare an array of ints. So in this array, num0 is going to be the very first. Remember, we index at 0 for arrays. And this is going to go all the way to num of index 4. So the general syntax for accessing array components is going to be this, where we have the array name and square brackets and then the index. And the index needs to be a non-negative integer. Some programming language allow a negative indexing, C++ does not. And this index value specifies the position of the component that we want to pull out. These square brackets are also known as the array subscripting index, and remember, we always start at 0. Okay, so for instance, if I made a list of size 10, I would have something like this. And notice the array structure. This is exactly how it is actually stored in memory. They're all stored one contiguous block after another. So if I wanted to set an array position to a certain number, I could use this syntax where I select what element that I want, and then I can set it equal to something. Here's some more examples where I index in. You can also, of course, set the array to something a little bit more complicated, where either you can use, you can use anything. Anything you can think of on this side, as long as it evaluates to an int, can be stored in an int array. Now, some things. So you can declare arrays in a variety of different ways. So you can also declare it using a const as your size. There's no problem there. However, you can't do the following. You can't have a int array size that is not initialized and then ask the user to tell you the size and then create an array of that size. That won't work because at the beginning when C++ is compiling your code, it needs to know how much space it needs to allocate in memory. And at this point, it can't do this on the fly. It has to do everything ahead of time. And so at this point, it doesn't know how much space to allocate until it gets it from the user, and that's too late. So this is not allowed. So some basic operations that you can do on one-dimensional arrays: initialize, you can input, you can output from them, and we'll also show an example of finding the largest or smallest element, so looping through it. All of these operations actually require the ability to step through the array, and loops are going to be how you want to do that. Okay, so consider this declaration where I declare an array of 100 integers. So now I want to loop through and I want to process the list in some way. So for instance, I may want to set all of the values equal to something. And in this example, I have read in from the user. I've asked them to enter in each one of the numbers, and I can store them into each element of the list. So here's another example. So at the beginning, I declare an array of doubles of size 10. I go through first my first for loop. I'm going to initialize all the values to 0. In the second for loop, I'm going to ask the user to give me values and initialize them with the values that the user gives me. In the next one, I'm going to loop through and I'm going to print out all the values. Oops, sorry. And in this example, I'm going to get the sum of all of it. So, right, I can loop through and I can just add something to a variable outside of the for loop and then find the sum. And then, of course, I can find the average, and I can do things more complicated like finding the largest element by adding some if logic in there. So the main idea here is that arrays and for loops are friends. So they are going to work together. That's how you're going to do most of the things that you want to do with arrays or with loops. Worth mentioning that array index out of bounds. The idea here is that we don't want to step outside of the bounds of our array and access or modify something that doesn't belong to our array. So imagine we have the following. We have an array of 10 doubles. So num at I, which is our array, is valid for all of these indices, all the way from 0 to 9. If I step one out of that and I try to index at, say, array size at 10, then I'm technically outside of my bounds. Now here's the kicker, is C++, there's no guard against this. So C++ is going to be perfectly fine with letting you walk outside of your bounds, which you have, so now you as a programmer have to be aware of this and control for it. And we'll talk in a little bit more in detail about what kind of issues this may cause in other lectures. Okay, so arrays can actually be initialized during their declaration. In this case, you don't have to specify the size because you're going to pre-allocate them, and the size will be determined by however many initial values you give it. So for instance here, you don't have to say that you're making a double array of size 5 if you're giving all 5 of the values here. You can also partially initialize the values of your array. So here I have made a array of size 10 of ints, and I've set the very first value to be 0. Actually, I'm sorry. So this is a special one. What this one does is it initializes all 10 of the components to 0. You just give it one indice or one value. However, this statement does something a little bit different. It will set the first 3 elements, so listed 0, 1, and 2, to 8, 5, and 12. Everything else is initialized to 0. So C++ is nice in that sense. When you do arrays, it will initialize. If you initialize arrays this way, it'll initialize everything to 0 and will partially initialize parts of your list depending on what you pass it. Okay, so same thing here. If you don't give it a size here, then again, it's going to just determine its size based on the components, how many components you give it. Here we have another example where we just initialize the first 2 values to 4 and 7. Everything else in this 25 unit array is going to be initialized to 0. So there are some restrictions on what you can do with arrays. So you can declare an array here, initialize everything, and declare another array that's empty at this point. And you might want to try to set these arrays like this. You can't do this. It will not work the way at least that you want it to. This is also illegal. You can't read massive so this is a list, not just a variable. You can't do a CN to just your your list. However, what you can do is you can loop through each index and set each index individually. The following are legal, but they don't give you the results that you think. So here, if I printed out my list like this, I would just get the memory location of the first element. I would not actually get the values of my list. Also, I can try to do a comparison here like this between two lists, and it will work, but it won't actually compare what I want it to compare. It will compare the memory locations, which is not the same as comparing what those memory locations hold. Again, we talked a little bit about how we may want to pass arrays as parameters to functions. It's worth noting arrays are always only passed by reference. You can't pass an array by value. You don't actually have to include the ampersand like you do with the other call by reference variables. But it is still by reference. So here I have passed these arrays here. Right. Oh, I'm sorry, I went backwards. Okay. Again, so if you are going to pass your array, you probably want to decide at any given point which one, if you want it to be constant or not, depending on what you're actually doing in the function. So here, if you're initializing your array, you're going to want to not keep it constant because you're going to want to modify it, right? We loop through and we set them all to 0. If we are printing an array, we are going to want to keep this constant. So we're going to keep this constant because we don't want to actually change it. We just want to print it out, right? Keep it constant. So the base address of the array is the first array component. So this is if you were to print out the memory location of an array, you would get the memory location of the first element. Right? So if list is a one-dimensional array, then the base address is the address of list at 0. And so when we pass an array as a parameter, we're actually passing that base address. And again, so lists are stored contiguously in memory. So if I were to return the memory location of my list, I would receive 1000. And it's also worth noting that notice that these are separated by 4. That's the size of an int, right? 4 bytes. So list at 1, that int value needs 4 bytes of memory to be stored in. And so each one of these is going to be, but they're going to be one after one another in memory always. So functions can't return the value of an array, so you can't return an array by value. You can get around this by returning a reference to an array, but you have to be careful about that because if you are in your function and you make your array and it's a local array, then if you return a reference to a local variable, then that local variable, as soon as that function is gone, is done executing, it will dump all of the memory that it was using, and so that's not going to work either. So C strings are character arrays and they're one-dimensional. They are always terminated by a \0. So this is the null character. So usually they're denoted by a double quote here. So A is a character, double quote A is a C string. And technically what is encoded here in this C string is A and this terminating character. So if we consider the following statement, this is a character array of size 16. So since these strings are null terminated with that null character and name has 16 components, the largest string that we can store in here is only going to be 15 because we still need one character to hold that one position to hold the null character. So what this statement does is we have a character array and we set it equal to a string. What it's going to do is it's going to store the name John in it, but it's also going to have one more position that is going to hold the null character. If we do it without declaring a size, that's fine. Again, it's going to automatically decide that it's of length 5, where it stores all the 4 letters in that null character. So using strings, we have some functionality. We have this str copy built in that will copy the value of one string into the value of the other. So copies the S2 into S1. So we also have this string compare that will compare these two strings and will return a integer value given what the evaluation concludes. And then we also have string length, which will return the actual length of the string, and it will exclude the null character, so it will give us the actual length that we're interested in. So strings are compared one character at another, one character after another. So here are some examples. We talked about this a little bit when we talked about strings. C strings are just the same. So suppose we have the following statement. So here we have declared 3 character arrays or C strings. And now if we copy this into my name here, then my name will be, of course, what we copied in, and the length is going to be 13. Now we can, of course, just straight up store that length. We don't have to, it does return something, so we can store the length. We can, copy things, we can compare things. So if we compare these, it's going to be less than 0, indicating that Bill is smaller than Lisa. So on and so forth. We can also do the comparison on character arrays and not necessarily just literal strings. So these are going to be really useful when we start to work with strings and character arrays. So reading and writing strings, so most of the rules that apply to arrays also apply to C strings. So aggregate operations such as assignment and comparison are not allowed on arrays, but we have some functionality that I just showed you with strings, right? So we have to use those auxiliary functions to do those aggregations instead of using the equals like maybe we might be used to. So so input and output is also done component-wise, so we'll have to loop through and set things one by one or print things one by one. The one place where C++ allows aggregate operations on arrays is the input and output of C strings, so that's character arrays. So for instance here, this is fine. We can do this. We couldn't do this with arrays, but we can do this with strings where we can directly input whatever somebody types in into a C string like this. You can also use the cin.get function to get strings with blanks, because remember when we use cin, it is going to be separated by spaces. So if you type in a sentence and you use this syntax here, you will only get the first word. But you can get around that by using the cin.get. Output, we can directly output this. We don't actually need to loop through. We can loop through each indice, but we don't have to. One thing that you can do is useful with C strings is to specify input and output files at execution time. So here you can make a program interactive by using a C string to get the name of a file and use that to open instead of having it either hard coded or be passed as a command line parameter. So we'll get more into this. So this is kind of discussing about that open function and how C strings work with it, but we'll talk more about this when we talk about formal file I/O. I meant to hide that slide, but as a little preview for pretty far in the future, we won't talk about formal I/O for a while. But with this, if you guys have any questions, please let me know, and thank you for watching.